Pre-algebra, lesson 32, variables and evaluation. So variables are algebra code for letters, right? So numbers that are letters, or numbers that we represent with letters because we don't understand what they are called variables. And then when it comes to evaluation, well, evaluation is what we do when we solve algebraic expressions. Like order of operations is an evaluation of different arithmetic. So when we say variables in evaluation, we're talking about the evaluation of letters. Now, it's not only letters, but it's how arithmetic is used on letters if we give these letters certain values. So here's a great example problem right here. So this is the algebraic expression, xy plus x, with variables. And then I wrote this kind of sloppy because I was trying to color code it. Let's see if I can correct this. I'm going to erase that. Let's say x is equal to 2 and y is equal to 4. I'm trying to color code it between red and orange so it's a little bit clearer. So they give us values for x and y. So the way that we solve these expressions is we're going to replace or substitute each letter for its actual number. And when we substitute it, we always substitute it inside of parentheses. Don't ever forget the parentheses. It's always inside of parentheses. So let's put this into action. Instead of writing x, I'm going to rewrite the whole problem, but I'm going to replace x with the number 2. So when I see x, y, instead of writing x, I'm going to put parentheses 2. Instead of writing y, I'm going to put parentheses 4, because I always substitute inside of parentheses. Okay? Then I have the plus sign, and instead of writing the number x, again, I'm going to put parentheses 2. Some of you may be wondering, why do I have to put all of these parentheses? Because eventually we're going to have to solve these problems with positives, negatives, fractions, exponents. There'll be multiple levels of brackets. There'll be square roots. It'll be all kinds of madness. And if you put the parentheses in there, it will make sure that you never make a mistake. So now that I've rewritten the problem, now I'm just going to use my order of operations, or PEMDAS. And I know that when two numbers are in parentheses and they're touching, that means to multiply them. So step 1 is going to be 2 times 4. 2 times 4 gives me 8. And then I have 8 plus 2, which gives me a final answer of 10. So the answer to this problem is going to be 10. Look at the letters, rewrite the problem with the numbers in parentheses, then solve. Alright, now let's do the next one. This next one has 3 letters. So we have x in red, y in orange, and then m in green. So instead of writing x, I'm going to put parentheses 2. Instead of writing m, I'm going to put parentheses 5. Instead of writing y, I'm going to put parentheses 4. Then I'm going to copy the minus sign. And then lastly, another x and y, so parentheses 2 and parentheses 4. Alright, now I'm going to solve using order of operations. So I'm going to use 2 times 5 times 4. 2 times 5 is 10. 10 times 4 is 40. And then 2 times 4 is 8. Then I'm going to do that subtraction symbol in between them. 40 minus 8 gives me 32. And that is my final answer here. So it takes a little while to plug it in, but it's worth it and you get the right answer. Don't ever forget the parentheses. Last example. What happens if they give me letters and then fractions and then a whole number? Cool thing is the whole number doesn't change. The 4 is going to stay the same. So that's pretty simple. Now the x, even though it's a fraction, still follows the same rules. Same thing with the m. So instead of writing m, I'm going to write 9/11ths. Instead of writing x, I'm going to write 2/3, which is the value for x. Then I copy the plus sign. I copy the number 4 because it doesn't change. And then I plug in 9/11ths for m again. Now I can see what to do again. I'm going to multiply and then add. So here when I multiply, I can cross cancel before I multiply these two numbers. Right, so I put a multiplication dot. I can cross cancel the 3 and the 9. 3 goes in 9 3 times, 3 goes in 3 once. Now I can multiply. 3 times 2 is 6. 11 times 1 is 11, so I have 6 over 11 plus 4 over 1 times 9 over 11. So we'll go ahead and turn that into a fraction. 4 times 9 gives me 36, and then 1 times 11 gives me 11. And luckily I have common denominators here. So for the last step of addition, I'm just going to do 6 plus 36, which gives me 42 over the denominator of 11, which will not reduce. So my final answer is 42 over 11. Oh, now actually I could turn it into mixed numbers. Sorry. So 11 goes into 42 3 times, into 33, and then I've got 9 11s left over. All right. So the example problem in the book has it written as a mixed number. We'll talk in class as to whether or not we want to do mixed numbers or improper fractions. It should be okay with improper fraction nowadays, I think, but we'll see. If you have any questions, let me know in class, or let me know on the website, and I'll see you in class.